Okay, then if we go back to the specific equation, we can see, let's write that out. We had two simultaneous equations, 2x plus 3y plus 2 equals 0, which we called equation 1. And we had 3x plus 4y plus 6 equals 0, which we called equation 2. And we found that the finite solutions to those equations were y was equal to 6 and x was equal to minus 10. Okay, so we determined, or we found that we had this thing that we called the determinant, which was useful in solving that equation in the previous video, and basically we came up with a solution such that we had x was equal to B1 C2 minus B2 C1 divided by A1 B2 minus A2 B1. Okay, if you look at the previous video, you can see how we derived that. So we said that we could represent that in as determinants. So this is a determinant, and it's the determinant of the coefficients. So if you remember, we go positive in that diagonal and then negative in that diagonal when we represented these determinants. So we said that it was B1 C2. So if we put B1 is 3, B2 is 2, so we said B1 C1 B2 C2. So that's B1 C1 B2 C2. So in our particular case, that was 3 2 4 6. So we're multiplying B1 times C2 and then subtracting B2 times C1 following this format, multiplying that diagonal and then subtracting the product of that diagonal. Okay, and then we divided that by another determinant, A1 B2 A2 B1. So those are A1 is 2, B1 is 3, which is 2 3 3 4, and again that's A1. Sorry, I should have written those. Let's go back. So A1 B1 A2 B2 is our general case determinant, and in our specific case, that is A1 is 2, B1 is 3, A1 is 3, A2 sorry is 3, B2 is 4. Okay, such that we got x is equal to, if we do the determinants, 3 6s are 18, minus 2 4s are 8, divided by 2 4s are 8, minus 3 3s are 9, which gave us 10 over minus 1, which gave us minus 10 as the solution. Similarly, we can do the same or a similar thing to bring this in terms of solving it for y, which we found y by using standard simultaneous equation methods, elimination methods. We found that y was equal to 6. Again, that's in the previous video. But if we now look at this, if we put this together as a in the format of these determinants, we are trying to solve for this now, so we need to eliminate x this time. So we are now looking at a. So if we were solving for y, so we have a1. Might help if I write that equation out generally. a1x plus b1y plus c1 equals 0 is our first equation, and then the general case a2x plus b2y plus c2 is equal to 0 is our second equation in general terms. So we're solving for this one now, so we have this determinant a1 c1 c2 rather minus a2 c1, and then we need to divide that this time. If we look at the coefficients that we're interested in, instead of being a to determine x, we're looking at the b's. Times the a. So this is b1 a1 this time, and this is minus b1 a2 this time, and then that's minus b2 a1. So this time then that is equal to the determinant a1 c1 a2 c2 divided by b1 a1 b2 c2 determinants. Okay, so essentially we've done the same thing, but this time eliminating to calculate y instead of eliminating y to calculate x. So we have a1 is 2, c1 is 2, a2 is 3, c2 is 6, so we need the determinant of that, and then that's divided by b1 is 3, a1 is 2, b2 is 4, that's this one here, and a2 is 3. So again, multiplying this diagonal, 2 6s are 12, minus 3 2s are 6, divided by 3 3s are 9, minus 4 2s are 8, which gives us 12 minus 6 is 6, divided by 9 minus 8 is 1, 6 on 1 is 6. And we've used that same method using these determinants to find that y is equal to what we found it to be in the standard format way of doing this. Y is equal to 6. The standard way of doing this was to we multiplied this equation by 4 and this equation by 3, and then subtracted one from the other to give us a value for x. And we're doing a similar thing, eliminating x to calculate y using this determinant method that we established in the previous video. So where does that take us? If you look at this determinant here, let's just change color. So this determinant here and this determinant here, you can see that they are essentially the minus 1 times the other. Okay, so whereas if you look at this one, when this was calculated out using our specific example, we got 8 minus 9 to give us minus 1. This determinant gave us plus 1, and that's because instead of this diagonal minus this diagonal, essentially this represents this diagonal, do beg your pardon, that there should be an A2, and that A2 is indeed the A2 there. So we've written that down here in the general case, but we put the correct value in here. So this is essentially the negative of this. Okay, B1 minus A1, sorry, B1 times A2 minus B2 times A1 is the equal and opposite value of this one here. So if we write that, or from that we can derive therefore that x is this determinant divided by this determinant, and y is essentially, if we use this same determinant, it's just minus. So let's write that out longhand or fully out. So B1 C1 B2 C2, the determinant of that, divided by A1 B1 A2 B2 determinant. We can say that y is equal to A1, so A1 C1 A2 C2, the determinant of that, divided by, and we'll use the same one but we'll call it a negative, so that makes the whole thing negative, and we'll just use this same version, which is the negative of that, A1 B1 A2 B2. Okay, so we've got the same on the top and the bottom, and we can test that just to make sure that we're correct, because that is in our specific case for this specific set of equations. 2 2 3 6 determinant, and now we've got this determinant here, 2 3 3 4 det, but we're making that a negative. 2 6s are still 18, 3 2s 2 6s are not 18, 2 6s are 12, 3 2s are 6, divided by 2 4s are 8, So we've got minus this, 2 4s are 8, minus 3 3s are 9. So we end up with minus 6 divided by minus 1, which is plus 6. So we can see that they're the same thing. But what we can do now, because we've collected those, or we've put those in the same terms, we can say that x divided by this one, so we bring in this down as an equals there, so bringing this down underneath, so b1 c1 b2 c2 determinant of is equal to 1 over a1 b1 a2 b2 and y over this one a1 c1 a2 c2 determinant is equal to minus 1 over this one a1 b1 a2 b2, the determinant of that. Okay, so we can combine those two results such that we get x over b1 c1 b2 c2 is equal to minus y over a1 c1 a2 c2 determinant, which is equal to 1 over the determinant of a1 b1 a2 b2. Okay, so if you make a note of that, and we will continue that in the next video.